Good day, viewers. I remain Ademola Johnson, your science tutor. In chemistry today, we want to look at Dalton's atomic theory. Dalton's atomic theory. Dalton's atomic theory and modification. You know, in 1907, a man called John Dalton stated some facts about atom. Okay, about 4 of the 5 points he stated were later modified due to latest scientific discoveries. So he stated 5 points about Dalton's, which were called Dalton's atomic theory. People were using it. But after a while, 4 of them, due to new modifications, were modified. Now let's look at some of them. Serial number. Let's look at Dalton's atomic theory. Dalton's atomic theory. Reason for modification. Reason for modification. Then let's look at modified theory. Modified theory. The first thing this man stated was that he said atoms can neither be created nor destroyed. He said you cannot create atoms, you cannot destroy atoms. But when there was a discovery of radioactivity, this theory was modified as during ordinary chemical reactions. Ordinary chemical reactions. That is when atoms can neither be created nor destroyed. So during ordinary chemical reaction, for example, you say hydrogen gas reacts with oxygen gas to give us H2O. If you did not balance this equation, this is an ordinary chemical reaction. Hydrogen has reacted, this one disappears for this one to be formed. So, but 2 atoms of hydrogen is here, 2 atoms, so hydrogen is balanced. You have not created hydrogen, you have not destroyed hydrogen. But here, you started with 2 atoms of oxygen, but you are ending with 1 atom of oxygen. You have destroyed 1 atom of oxygen. So to show that you have not destroyed, then you need to balance the equation. Now, you need, because of these 2, you now put 2 here. So when we have this, then but the 2 you have put here is for oxygen, is also for hydrogen. Hydrogen is now 2 times 2, 4. So you now need to put 2 here again. So then the equation is balanced. So the balancing of chemical equation is based on the fact that during ordinary chemical reaction, atoms can neither be created nor destroyed. But in radioactivity, it is possible. Like look at 238 of uranium, 92, can form 234 of thorium of 90 after emitting alpha particle. This alpha decay. So uranium, if you put uranium inside a cup, come back in the afternoon, you will not see uranium again. The uranium would have been destroyed to form thorium and emit alpha particles. So, so there are two types of reactions. Now we have radioactive reactions, and we have ordinary chemical reaction. This law is possible for ordinary chemical reaction, but it's not possible for radioactivity. You can see there. Uranium is destroyed for thorium to be formed. So that is that. Now, another thing this man stated, number 2, he said that matters are made up of tiny, indivisible, or indestructible particles called atoms. Can you see what this man said? He said matters are made up of tiny particles, and those particles cannot be destroyed. And he said atoms. What about the discovery of the 3 atomic subparticles, such as protons, neutrons, and electrons? How can you say atoms cannot be divided when it contains proton, neutron, and electron? And for it to form ion, it either loses electron and form ion, or gains electron and form negative ion. So this one can lose electron and gain electron. Look at this one, it's losing alpha particles, some of the proton, so it can be divided. Atoms can be divided. So they now corrected it that it is true that matters are made up of tiny particles called atoms. Don't say it, don't put so this adjective, indestructible or indivisible, is immaterial. It's not important. It spoils that show, because both ordinary chemical reaction and radioactive reaction show that particles can be emitted, can be gained by atoms. So it's not atoms are divisible. So then they have to correct it. Then another point, number 3, he said atoms of the same element are similar in all respects and are different from atoms of different elements. It is true that atoms of hydrogen is not the same as atoms of oxygen. They are atoms of different elements, so they are different. But the problem here is that he put in all respect, they removed it. They said, we should have said that atoms of the same elements are similar, not put in all respect, and are different from atoms of different elements. He should have stated it like this. Why is it so? Discovery of isotopy. So isotopy, e.g., we have H11, H21, and H31 are isotopes of the same elements, hydrogen. They have what? They have the same atomic number, but different mass number. So why did you now say they are similar in all respects? What about elements that exhibit isotopy? They have the same symbol, they have the same atomic number 1, 1, 1, but mass number of this one is 1, this one is mass number is 2, mass number of this one is 3. So the discovery of isotopy countered this. So atoms of the same elements are truly similar, but not in all respects, because members of isotopes have different mass numbers. Then let's look at two other points he stated. Now, number 4 now. He said a molecule of a compound is formed from the combination of two or more than two elements, two atoms of different elements in simple whole number ratio. This way it causes problem. It is truly from here. This is an element. When they combine, they form a molecule, they form compound. And in this molecule of water, you have, if it is H2O, you have 2:1. The ratio of hydrogen atom to oxygen atom in this place is 2:1. That's what he meant by simple whole number ratio. But the discovery of polymers, e.g. starch now, the molecular formula of starch is C6H5O10. Okay, H10O5N, where N is equal to 10,000 to 15,000. So if you put 10,000 here, use it to open this bracket. 6 times 10,000, that's 60,000. Then 10 times 10,000, that's 100,000. 5 times 10,000, you know what it is. This number will give a complex ratio, not a simple whole number ratio. So that is that. So you should have told us that a molecule of a compound is made from the combination of atoms of different elements. Yes. Then it will be taken. So this is the modified fact. Then the last one is stated that nobody has ever counted up to now. Is number 5. He said all chemical reactions involve the separation or combination of atoms. So nobody has ever counted this up to now. So all chemical reactions involve combination of atoms to form a molecule or separation of atoms. So we are stopping Dalton's atomic theory here. In the next class, we'll look at physical change, chemical change, and we'll look at mixture. And then finally, in SS1 scheme, we'll be talking about separation techniques. See you then. I remain Afiademola Johnson. Please subscribe, share this video, put in the comment section your worries, and I will attend to it. God bless you. Have a good day. Thank you.